Welcome to this video, exploring essential Spring concepts. After watching this video, you'll be able to describe essential Spring concepts and explain their role in Java programming. Deploying Java code once involved several complex steps, such as manually configuring environments, checking dependencies, and carefully tracking down errors. However, the Spring framework has simplified this process. Let's explore the essential components associated with the Spring framework. Applications are programs built using the Spring framework. They comprise various components such as beans, services, and configurations. These components work together to perform tasks, allowing the application to handle requests, manage data, and implement business logic. Beans are objects managed by the Spring Inversion of Control, or IOC container. They are fundamental to a Spring application and form the core components that provide functionality in a Spring application. Simply put, a bean is like a piece of furniture in a house. Each item, such as a sofa or table, contributes to the house's functionality, just like a bean serves a specific purpose to the program. The application context is the central component of the Spring framework. It manages the beans and their dependencies throughout the application's lifecycle. It is like a manual or ready reckoner that provides the instructions for creating and managing the various beans that make up the application. It ensures that all necessary components are available when required. Configuration involves the setup and management of Spring components. It can be executed through XML files, Java annotations, or Java-based classes. The configuration is like a building's blueprint, which outlines how each room or bean should be constructed and maintained within the structure. Annotations simplify configuration by serving as metadata. They provide key information about how beans should be managed. For example, the @component annotation marks a class as a Spring bean. Annotations act like labels on a product, providing important details about its contents without needing separate documentation. Dependencies refer to objects that other objects require to function properly. They enable objects to work together effectively within an application. For instance, cars require engines to run, which implies that the engine is a dependency for the car. Inversion of control, or IOC, is a key principle that transfers the responsibility of creating and managing dependencies from the application code to the Spring framework. Rather than manually creating objects, such as an engine for a car, Spring provides the necessary components when initializing beans. This process is akin to ordering food at a restaurant. The chef prepares the meal for you, thereby creating and managing the dependency on your behalf. Dependency injection, or DI, is a technique that allows dependencies to be injected into objects at runtime. Spring automatically provides dependencies instead of allowing an object to create them. For example, if a car needs an engine to operate, Spring injects this engine into the car when the car bean is initialized. Auto-wiring is a Spring feature that automatically injects the necessary dependencies into beans without explicitly defining them in the configuration. Spring uses reflection to match the correct beans based on their type or name. Auto-wiring can be compared to an automatic coffee machine, which brews coffee with little manual intervention. It eliminates manual defining and wiring dependencies. Components are classes directly managed by the IOC container. They are annotated using @component and can be automatically registered as beans within the Spring container. Components can be services, repositories, or any other application part. They are similar to departments within an organization, each responsible for specific functions, working together to ensure the smooth operation of the application. Aspect-oriented programming, or AOP, is a programming paradigm that works alongside object-oriented programming. It improves application maintainability by isolating concerns relevant across multiple parts of the application, such as logging, security, and transaction management. AOP can be compared to adding layers to a cake, where each layer represents a different aspect, such as flavor or decoration, contributing to the overall structure without altering its core. In this video, You learned that Spring simplifies Java deployment by automating configurations, managing dependencies, and efficiently handling errors. Applications in Spring comprise components such as beans, services, and configurations that handle requests and business logic. Beans are objects managed by Spring's IOC container and provide functionality in a Spring application. Application context is the central manager for beans and dependencies throughout the application's lifecycle. Configuration defines how components are set up using XML. Java annotations, or Java classes. Annotations simplify configuration by marking components. Dependencies are objects required by other objects to function properly. IOC shifts dependency management to Spring, reducing the need for manual object creation. Dependency injection allows Spring to inject dependencies at runtime instead of having objects create them. Autowiring automatically injects dependencies based on type or name without explicit configuration. Components are managed by IOC and registered within the Spring container. Finally, AOP separates cross-cutting concerns such as logging, security, and transaction management.